Welcome to Calculus Homework, page 240. We're looking at this function, and they want us to consider it where x is equal to 2. First of all, they ask us to do a graph from the graphing calculator. When we do that, we get this graph. Notice that function does not exist between -2 and +2. I wonder why. If we look back at the function, if x, for example, was equal to 0, 0 squared would be 0 minus 4. That'd be the square root of -4, which would be equal to 2i. That's an imaginary number, and therefore it does not exist in the real numbers. And in Calculus 1, we do not do imaginary numbers. So the function does not exist between -2 and +2. We're going to be interested right here where x equals -2. Okay, based on the graph, is that function continuous at 2? And of course the answer is no. Let's talk about explaining our reasoning why. So they want us to talk about the continuity. The first step in continuity is, first of all, to find out if f of 2 is defined. So we can take our function and we plug in 2. 2 squared is 4, minus 4 is 0, the square root of 4 is 0. So yes, it is. Okay, when x is 2, y is 0, you can tell right there on the graph that is true. Okay, the next step in continuity, remember, is to find out, okay, does the limit of that function exist as x approaches 2? First of all, we can look at the graph. As x approaches 2 from the left, we know y equals 0. But as x approaches 2 from the right, x approaches 2 from the right, y is 0. As x approaches 2 from the left, it doesn't exist. Let's show why. Let's approach 2 from the right. And let's plug in something like 2.0001 squared minus 4. That's essentially 4 minus 4. That gives us 0, and we see that point there. Then if we try the limit as x approaches 2 from the left, we plug in something like 1.99 squared minus 4. This is not quite 2. If we square it, that's not going to quite be 4. We end up getting an imaginary number which does not exist. So the left limit, the right limit do not agree. The answer is no. And so for that reason, we can stop right here, okay, and say the function is not continuous. If you'll recall, the third step in proving continuity was to say that the function value at that point was equal to the limit at that point. And since this does not exist, there's no way you can say that. So there's no need to even go to step 3. All right, we also want to know if it's differentiable at 2. That's easy. Okay, first of all, just looking at the graph, let's try. If the limit does not exist there, we know the derivative cannot exist there. But let's prove it by using our derivative. The derivative, that's x squared minus 4 to the half. That's half. X squared minus 4, negative half. That was the derivative of the shell. The derivative of the chocolate is 2. x. So the 2's are going to cancel. We're going to be left with x over square root x squared minus 4. And now we want to know alpha, the value of the derivative at 2. So if we plug in a 2 here and a 2 here, we get 2 over 4 minus 4 is 0. The square root of 0 is 0. We know that we cannot have 0 on the bottom of a fraction, so that limit does not exist. And since that derivative does not exist, that function is not differentiable at x equals 2. So no, it is not differentiable. Okay, and that is our homework, page 240. Thank you for watching.